In this next video, we're going to talk about the other type of friction. The other type of friction being the friction that occurred here when we were pulling it at constant velocity. And we said it was sliding. We were saying it was sliding. And we had a mean value of 5.773 newtons. So I'll just write that for the mean value at 5.773 newtons. Now, this kind of friction is called, has multiple names. You'll see it referred to differently in different contexts as sliding friction, dynamic friction, and the third one, which is such a bad name it should never be used, but you will still see it, is called kinetic friction. And you should never use the word kinetic friction because it creates misconceptions. Kinetic friction generally means moving, and we'll see why in the next installment why we don't want to call it moving friction, because moving friction doesn't necessarily mean static. So the best name is dynamic friction, and the dynamic refers to the idea that there's this surface and this surface, and one is moving relative to the other. And so that's a dynamic interaction. It is also sliding on a macroscopic scale. So we can define this mu dynamic, which we'll call mu d, as the force of friction, dynamic, divided by the force normal. And the force of dynamic normal was 5.773, and I believe I told us that the force normal was 15.246. And that gives us a 0.378656. And so four significant digits gives us 0.3787 would be the mu dynamic. Now, of course, we could use the 5.773 plus the standard deviation, which was 0.26, and the 5.773 minus the 0.26 for the upper limit. And the lower limit, and those would go in here, and we would get different numbers, which would give us a larger and a smaller, and we could express that with the uncertainty. And you may wonder, why is this, so what really fundamentally physically is different about that? And fundamentally what's physically different about it is if it's static friction, we have to apply enough force that the upper surface rises up. But once it's already risen up and started moving, it is now can skim across the top. So you can see that if these two are pressed together and I have to pull it sideways, it's going to be harder to pull this hard enough that it rises up than it will be to keep it moving and sliding across the ground. And so in some ways, this is partly why we have the misconception that it takes more force to start something moving than it does to keep it moving. Now we know that is not true. The inertia is the same for a body at rest versus one that's moving. We know that about the law of inertia. But there's a little bit of truth to it in our frictional world. A little bit of our experience says it does seem a little harder to get something moving than it does to keep it moving, but only with regard to overcoming friction. And so that is sliding and dynamic friction.